Welcome. This video is going to look at ions, how they form, and then what their radii would look like compared to when they were a neutral atom. So an ion is an atom that has a charge because the atom has gained or lost electrons. Remember, chemical reactions are all about electrons being gained or lost so that an atom picks up a noble gas electron configuration. And protons are tucked way down in the nucleus, held far too tightly for that to be part of our chemical reactivity. That's something called a nuclear reaction. So an ion is an atom that has a charge because the atom has gained or lost electrons. If it gains electrons, it becomes a negative ion. And unfortunately, that's the opposite of what we think of in math, but that's the way it is. Electrons have a negative charge, so more of them makes the atom negative, and so then we call it something called an anion. If it loses electrons, it becomes a positive ion because now there's fewer negative electrons compared to the positive protons, and we call it a cation. So when an ion forms, the size of the radius of the atom also changes, just like you'd expect. When you gain something, you get bigger. When you lose something, you get smaller. So again, larger atoms will tend to lose electrons more easily because the electrons are further from the positive nucleus, which is what holds on to the electrons. So the electrons are looser, they're held more loosely, they're easier to be pulled off by a neighboring atom that wants the electrons. So metals, which tend to be the larger atoms, lose electrons, form positive ions since they're larger than the nonmetals. Smaller atoms then tend to gain the electrons more easily because electrons are closer to that positive nucleus and held more tightly. So nonmetals tend to gain electrons and form negative ions since they're smaller. So remember, lower left, larger losers, upper right holds them tight where your nonmetals are at. So negative ions are going to be larger than the atom they started as because there's more electrons, but the nucleus is the same size and strength, so there's more crowding. Even though you haven't added another floor, there's more crowding on that floor, and so there's electrostatic repulsion among those electrons. So the atom gets a bit bigger when you add electrons. Positive ions become smaller because there's fewer electrons, and in fact, usually you empty the outer orbital. Okay, so you empty that floor that only had 1 or 2 electrons on it, so that becomes a whole energy level smaller, and the nucleus is still the same size and strength. So there's going to be far less crowding and less electrostatic repulsion among the electrons. So the ionic radii trends really are very similar to the atomic radii. That ionic radii will increase down a family because there's another energy level, so there's more electrons to shield the valence electrons from the pull of the nucleus. And ionic radii decrease across a period because it's the same energy level, but the nucleus is getting more positive and stronger. But the one thing you should remember is negative ions will always be bigger than any positive ions. So compare what happens when sodium loses 1 electron compared to fluorine gaining 1 electron. So if you find sodium is number 11. So its electron configuration is normally that of neon and then 3s1. Oops, let me try that again. So when it loses 1 electron, what's left is just the configuration of neon, which is great. That's what we wanted, was a noble gas configuration. But it's still a plus 11 charge pulling on now what's left of the 10 electrons. With fluorine, fluorine's number 9, and so its noble gas configuration is helium, 2s2, 2p5. So when it gains an electron, I'll show the electron being lost there, when it gains an electron, it becomes helium, 2s2, 2p6, the plus 1 charge, or that's really neon with a plus 1 charge on it. I'm sorry, with a minus 1 charge on it. So now I've got fluorine with a plus 9 charge and 10 electrons, and I've got sodium with a plus 11 charge and 10 electrons. So sodium is going to be smaller because it's got the stronger nucleus pulling on 10 electrons, and fluorine is going to be much bigger because it only has a +9 charge pulling on those 10 electrons. So even though both of them are mimicking neon's noble gas configuration, we are going to see a much bigger ion with fluorine than we do with sodium. Try it here. Predict which atom or ion is larger. And you might want to pause here and take a look at what you would see as the nuclear charge or number of protons and electrons in each of these and make your prediction. So Mg, if you look it up, is +12. It's number 12, so it's got 12 protons. And in a neutral magnesium atom, that means it also has 12 electrons. But Mg2 plus means it's lost 2 electrons, so now it only has 10 electrons. So which one's going to be larger? Well, 12 electrons is going to take up less space than 10 electrons if they both have the same charge pulling on them. So Mg is going to be larger than Mg2 plus. Again, you might want to pause here and try this on your own, but predict which atom or ion is larger, S or S minus 2. So if I look up sulfur, sulfur is number 16, so it's got 16 protons, and the neutral one has 16 electrons, whereas sulfur 2 minus is 16 plus, but now it has 18 electrons. So now sulfur 2 minus is going to have more electrons crowding and be quite a bit larger than sulfur, the neutral atom. Try it number 3, predict which atom or ion is larger. You might have to look at the table to predict this, but remember when you get to your test, you should be able to predict this without having a table with pictures of the ions on it. Calcium 2 plus or barium 2 plus, they both have the same +2 charge on it, so the charge on the ion isn't going to become a factor. So instead, what is a factor is where they're at in their respective family. And calcium is only period 4 versus barium period 6. So I can assume barium +2 is going to be quite a bit larger. This one, a little bit different. Predict which atom or ion is larger. Chlorine -1 over here in family 7, or phosphorus -3. Well, if phosphorus has gained 3 and chlorine's only gained 1, I would expect phosphorus to be larger since it's gained more. And then chlorine -1 versus aluminum +3. This one, I don't even have to look at the chart. Positive means it's losing and becoming smaller. Chlorine being a negative charge is gaining, so it's definitely going to be the bigger one.